good. Yes, looks all right. Okay, and wait, did I share my screen yet? I think so. Can everybody see this? They get like a little presentation here.
No, you were frozen.
Not yet. Yeah.
Oh, okay, okay, here, let me just reshare then. So I will share a screen. Is this working at all?
Nothing yet.
Nothing yet. Okay, okay. All right. Well, in that case, I can still just do the introduction and then lead us into it. And so, welcome to the this is like the second OpenStack meetup. I call this one like the summer 2022 one. And so just a little bit about myself. My name is Forrest. I'm the incoming vice president of the Carleton Computer Science Society this year. And I've been at Carleton for quite a long time. And I've run quite a few different projects that make use of the OpenStack cluster. And so with a lot of these projects, I've been able to, I think sort of like my main goal is to be able to like propel students in what they can do and allow students to run projects on the infrastructure and help them out with it and stuff like that. And so that's what this meetup is like sort of is taking a look at like how is the OpenStack being used and what types of things are happening both on like the student side, then also with like the TA side a little bit and the hardware side. And so for today's schedule, we have 3 different sections. It's more or less informal. First of all, we'll be hearing from Andrew Pullin about some of the upgrades that will be happening to the OpenStack infrastructure in the coming weeks. After that, we'll hear from Christopher Bellman about how the OpenStack cluster has been used for tutorials and labs, I guess mostly labs for the 4th year security course. And then I'll give a little bit of an update on how some things are going with the Carleton Computer Science Society student summer projects that we have going on. So yeah, more or less just kind of hearing what kind of stuff's going on, and hopefully, so I think one of my goals is students can come watch this and then get some more information about some of the stuff going on behind the scenes, because there's a lot of cool stuff and it's always cool to talk about it. So Andrew, I'll hand it over to you if you want to share a little bit about the infrastructure changes coming.
Yep, will do. So just let me
Yeah.
share my screen here, assuming it'll work.
I'll have to figure out my my screen share as well. All right, let's see here.
Okay, so
perfect. Looks good.
Did that show up?
Yes.
Okay, so first of all, I'll just open up a photo quickly of the current layout of things so people can sort of wrap their brain around that. And there we go. Okay, so drag this over. Come on, Windows, expand. Okay, can everyone see that?
Yeah, looks good.
Server racks, okay. So this is shot from this morning. So this is sort of where things stand now. For anyone who's looked at photos of the setup before, the big difference you'll notice is on the right side. There's now a 6th rack, so that was just added recently, and that's for Yuhong's research group. So that's got all these new GPU servers on the right. Can you actually see my mouse when I'm pointing at anything, or does that not show up?
Oh, you're good. You can see it.
Okay. So that was the first thing we set up recently, and then as we were doing that, we depopulated rack 1 on the very left-hand side here and performed our modifications. So our modifications are twofold. One, we're making all the racks deeper. So a lot of the GPU servers are just so long, they're bumping into the original set point for the racks. So that's the first step, is taking everything out and deepening the racks, and then putting all the infrastructure back in. And the next thing we're doing is updating the power. So we're adding additional circuits to each rack, and we're distributing it a little bit better. So they'll all still have UPSs at the bottom, And then they'll have some additional 220-volt circuits coming in and some additional just little 15-amp circuits coming in. So that's the purpose of this, is to really get the proper depth and get a whole pile of additional power available. So any of you who were on this morning might have noticed at 8:23 this morning, there was another power blip because of this very problem. So that affected rack 3 and 4 in the middle. So a couple circuits blipped down for some reason, and probably due to load. And they the servers that had redundant power, they were fine. So as soon as the power came back, they were good to go. On the plus side, the modifications I made to the OpenStack config is now successfully restarting instances after a power failure. So that wasn't working before, but I figured out the config problem finally. So that's one good thing about all this. But hopefully this work will get rid of the power problems permanently. We shall see. So there's 3 remaining OpenStack racks. So rack 2, rack 3, and rack 4 that need to be modified. So our goal is to do approximately a rack a day, and that'll give us a bit of extra time during the week to do some final cleanup at the end. So based on how fast we got rack 6 and rack 1 done, we should be able to do that. The first rack is going to be rack 4. So if I hop over to my little document here, so this is sort of the chronological order of everything that's being done on these racks. So as you'll notice, a bunch of the stuff's been done already. Rack 6 is done. Rack 1 is essentially done. And a bunch of stuff on Peter's rack 5, which does not have OpenStack equipment, but it still needs some things done on it. So most of that is done as well. So starting Monday morning, we're going to be doing rack 4. So rack 4, I'll just pop back over. Oh, I think someone's in the lobby, if you can let them in.
Oh, yeah,
So I'll
good.
pop back over. So rack 4. This is going to impact some of our grad students who have borrowed some of our teaching GPUs. So we have 16 GPUs on 2 of these GPU servers. So a lot of our grad students are using those this summer. So they're going to have to be prepared for some downtime on Monday for those. And then the courses are going to be the other big impact. So the nodes up on the very top here are sort of the core nodes, the big ones that run lots and lots of our little OpenStack instances. So fortunately in the summer, there's only around, I think, 30 to 40 students running instances for the undergrad courses, at least the last time I checked, I think last week. So it's not a huge impact. So but they will be down for a chunk of the day. Rack 4 is probably going to be the most complicated because we also have to install some new networking and things on it. So I expect those nodes will be down for probably, I would say, at least a few hours in total before we can take them out and put them back. So that will be the first step on the Monday, and we'll see where we get with that. If we're running really well, some of these nodes, for redundancy's sake, are going to be relocated over to rack 2 and rack 3. So if things are going pretty well, we might, instead of putting them back in here, we might temporarily put them maybe on rack 6 or something, so that we're ready to move them right back into rack 2 and 3 without impacting rack 4 again. So we'll see how that goes. Either way, there will likely be a second outage of a bunch of those nodes when we move them to their final location later on. So the next step is going to be rack 2. So this will likely be Tuesday. And this will impact our researchers. So there's only actually one research group, DMCL. So that's Weishi's research group, has a GPU server here. So this will be down, but we intend to move all of our research gear from rack 3 over to this rack as part of the process. So again, we'll be evacuating this whole rack and moving, most of the equipment will be moving back in. Some of it, like the GPU, the smaller GPU servers at the top, will probably move to rack 4 that we finished setting up yesterday or on Monday. and then we'll be moving the other research servers. So that's Giggle and Chorus research groups with Oliver and Sonia will move down. And Sonia's will take a little bit longer because we're also doing some hardware upgrades on one of her servers at the same time. The bigger problem with this rack on Tuesday is this also has the storage server for all the NFS mounts. So that's all the network storage mounts that many of our bigger instances have, especially for a lot of faculty who needed more storage space. They have network storage that goes to our storage server here. So that will be down for a little while. So we'll be sending out warnings about that. So the safest thing would be probably to shut things down. So I see Anil's here in the meeting, so he would probably want homeostasis shut down, or at least maybe unmount that just to be doubly safe for that outage. Go ahead.
The volume storage is so the extra storage. I mean, I have like an external volume. It's not NFS mounted, but it's just another disk. So that's also on the file server, right?
Yes, that's right.
Okay, yeah, so, yeah, definitely shut things down.
Yeah. So and then also it won't have a huge impact on people who are already connected to nodes, but the main OpenStack controller will be shut down for a little while. That outage will be pretty quick because we plan on moving it over to rack 6 so it can get back up and running. But the OpenStack web interface won't be accessible. You won't be able to, like things that are up should be fine, but you won't be able to set up anything with new networking or anything like that. All that functionality will be down until we get the controller moved over. And then at the end of the day, it has to move back. So once we have this rack all fixed up, it will be going back there. So at the end of the day, we'll have hopefully all the research equipment besides Yuhong's group will now be in rack 2, and those controllers will be back here and up and running. And that rack should be done. And then moving on to Wednesday, at this point, a good chunk of rack 3 is actually depopulated because things will be moving out to spaces in other racks, including especially the research servers. So this one might hopefully be a little bit faster. It also doesn't have any of the controllers or anything like that. It just has some of mainly the older compute nodes, and these don't have as many things running on them, and they don't have any of the things that are running sort of the more redundant. So some of the faculty, for example, in the research groups, I've set up redundant flavors that guarantee RAID and redundant power supplies on the nodes, and none of these on that rack qualify for that. So these tend to have less vital things running on them. And so hopefully by Wednesday that'll be done. There will be a bunch of cleanup then happening for the next couple days. Network stuff is going to have to get moved around and tweaked. So there'll probably be intermittent network outages as we move cables and stuff like that, but it shouldn't be anything that will severely impact people. Of course, the big caveat with all this is if something goes drastically wrong during this process, then who knows? But in theory, it worked pretty well when we did it for rack 1. That was our sort of test case, and it was pretty smooth. We had all the power ready and pre-laid out. So it was pretty quick and seamless. So hopefully that'll be the case again. And let me just check my other document, but I think that covers pretty much everything. Yeah, I think that's sort of it for that topic. So I think I can stop this share now if I can figure out how to do it. Okay.
All right. One question I was wondering about. So I think you mentioned in like the schedule for today, there was something about V3 of the OpenStack. What were the details on that?
Okay, so yeah, that's was that my third item? I can't remember what I told you.
Oh, good, no worries. I think that's the third item. Yeah, SCS OpenStack V3.
Okay. Yeah, so I'll quickly just mention the power limitations going forward.
Oh yeah, perfect.
We are getting to the max circuitry available in that room. Physics has 3 big 220-volt circuits that in theory will go to us when we need it, but that'll basically give us potentially another rack worth at most. So there will, I guess, for researchers, we'll have to start having a conversation about what happens when we run out of space and power. So, and unfortunately, we haven't heard any firm details from science. They're still looking at options for future data center type stuff that we will all, in theory, eventually move into, but that's a ways down the line. So, but not really much to say there, but just want people to be aware of that fact. The version 3. So I'm working now on the version 3 of OpenStack. So the current one is Stein, which we call version 2 internally, and version 3, which is being built on Ubuntu 22.04, is using Yoga. So, and that has a nice LTS of at least 5 years, hence the choice. So that is being done a bit differently. Version 1 and 2 were all done directly on hardware. Now version 2, everything's being set up on LXC, so which gives us a bit more flexibility. It's all being done on containers, and it's being developed with high availability in mind. So the goal is to we'll ultimately have 3 or 4 controller devices that are spread over a couple of the racks, each with redundant power, and then we'll have redundant services spread across the various nodes. So right now we have a few critical points, like if our main controller goes down, everything is out until we get a new controller up and running. So and obviously we have backups and stuff of that so that we can do it as quickly as possible, but there's definitely downtime. So the goal with the new version is that there's going to be much better availability for that. So, and more immune to if we do have power outages on a particular circuit. Again, hopefully that won't be as big a deal once these changes are made, because all of our controllers will have redundant power on going to separate racks, separate circuits. So it should be better than it is now. In fact, our original controllers, none of them had redundant power or RAID. Like it's pretty pretty minimal. So whereas everything, all the newer stuff, it's all rated and it's all redundant and all containerized to make it easier to move things around. So other than that, any questions about that?
So one thing I was sort of wondering about, so with like so you mentioned that physics is going to offer some of their power, so it should hopefully reduce some of like the downtime and stuff like that. And so what I was curious about is, would there be a way for us as users to sort of have one instance that we know is like very unlikely to go down, that we could use as our main one if we have like, let's say like 15 or something like that?
Yep. So I'm already doing that with faculty and at least one student group. I've set up a flavor. I forget who it was, but and that guarantees it's launched on a node that has redundant power and redundant hard drives. So, and that's definitely something we can set up. So I don't have bonding on any of the servers, just because we historically haven't had enough network connections on the servers. But in theory, some of the new servers with some additional network connections, we might be able to bond so that we can have redundant networking as well to different switches, but that's not something we've set up yet on anything other than like controller systems. So I don't know when or if we'll be doing that on nodes, but we can definitely give redundant power. So just send me an email, let me know, and I can create a flavor of whatever size, and it'll just be tagged so that it can only end up on a server that has RAID and redundant power.
All right, perfect. I just want to check if anybody else has a question before I ask a second one. Super, okay. All right, so this is more of like a big picture type of question. And I don't like, I'm curious about like just like a general answer, but with like the number of students increasing year after year, and potentially the amount of courses using more VMs, how much semester by semester is it increasing, like that a certain amount of capacity is needed, or it's just like a certain amount being used? Like, are we like, do you feel that we're running closer and closer to like the bounds?
It depends on certain things like GPU, where we just can't keep up with demand, obviously. So every time we get a GPU installed, it's gone within what, minutes, Andrew? Generally. So with compute, we were really tight a few years ago, but we've been much more proactive in buying like big systems with a lot of RAM. And we're really been able to take advantage of the fact that people have been using really lightweight instances, and in some cases even running like we give them a big instance and they run containers that are really lightweight within that, so with LXC or Docker or whatever. And so we haven't maxed out on our compute for courses in probably since just before the pandemic.
Okay.
So we've added a fair bit of hardware, and in fact, we have 3 more nodes that have been installed just recently. So that do they have, what was it, Andrew? 768 gigs of RAM on each of those, or a
Yeah, that
terabyte?
sounds right. And 64 cores,
Nice.
virtual cores. Yeah, they're pretty powerful.
So
They have about 8 terabytes of disk space. That's SSD.
and they're all rated as well. So like all of our newer generation of compute nodes are also rated. So knock on
210
wood, we
gig.
haven't had I think we've only had 1 or 2 hard drive failures, and that was a few years ago, unfortunately, on nodes that didn't have RAID, so students lost stuff. And but so far we haven't had anything fail on any of the new nodes. One researcher had one of their rated hard drives fail, but just plopped another one in, was all good. So.
Yeah, so for us, we usually ask at the beginning of the term, we ask faculty who needs equipment and how much equipment do you require, and then we try to calculate how many resources we need, and if we need more, then we request for more resources, and it's increasing every year. And if every course would use OpenStack, we would not have enough compute resources. Luckily, they're the system of asking and then we deliver for what has been asked has been working for us so far.
Yeah.
All right.
But obviously, we're going to continue to ramp up based on demand. So we're going to keep getting nodes, and the compute for teaching will continue to get priority access in the server room. Like if it does get to the point where power has to be rationed, then it'll be telling researchers, no, we're not going to be able to put your equipment in our server room. So it might be like, okay, you're going to have to install it in your own research lab, at least temporarily, until we get more space somewhere else. So we'll keep giving the space to the courses. So that's the primary function. So running things on OpenStack for researchers is sort of like a great bonus of the system, because it makes management easy for us and for the researchers. So and better, in theory, stability in a server room when it's functioning well. So although with our past air conditioner and power problems, I'm not sure how happy everyone is about that choice, but in theory it should be a stable location for that equipment.
Yeah, that's fair. That's fair.
A quick note about version 3. The goal is for it to be running for the fall. The most of the big courses won't be moved on it, so we'll run both OpenStacks in parallel. A few of the new compute nodes will go on the new OpenStack, and I'm going to run probably at least 1 or 2 courses. I was actually going to send an email to Anil. I was hoping he might volunteer as one of the courses that I'll run off the new OpenStack initially, so people can try it out. And
Yes, of course, happy to.
and worst case, we fall back to the old OpenStack, and I bump the nodes back over there if we need the compute capacity. So, and then as researchers, we have researchers with equipment coming in. So some of those, depending on timing, I'm hoping to put into the new OpenStack as well, so they can try it out. And then if everything's working well, we'll gradually over the air, same as the last time we upgraded OpenStack, we'll gradually start shifting stuff over as it's convenient. So, and timing it with courses and research demands and everything else. So the first time we did it, it basically, I think we started around November and finished the entire process around March or April. So we weren't in a rush. We just did it when it made the most sense to move things over until finally the old system was retired. So.
Yeah. Okay. Well, that's pretty exciting to have it hopefully ready by the fall there. Yes, we'll see how that goes.
And obviously for groups like computer science, for the Computer Science Society, it like we can run 2 projects in tandem. So we could set up a project for you on the new system. You can start playing with things on that, make sure it's working the way you want, and then gradually we can move your instances over, snapshot them, move them over, and then eventually retire it on the old system. So
yeah. Like
but we'll definitely keep both running in parallel for a decent amount of time, so that if we do run into an unexpected problem, we can fall back on the old setup. So the beauty of it is, it's like it takes 20 minutes, 30 minutes to prepare a node, like to put a base image on it and then push out the OpenStack services. So like on this side, on my side with version 2, it's my scripts do it. On the new one, it'll probably be done with Juju, or a combination of Juju and my own scripts, because a bit of the stuff we do, Juju, there don't seem to be any good recipes out there for it yet, so we'll see what happens. But I'm assuming it'll be a similar deployment time for Juju, so it's pretty quick to move nodes back and forth. So it should be pretty easy to run both in parallel.
Perfect. All right. Any other questions before we move on? All right. Well, thank you very much, Andrew. It's always exciting to hear. And I mean, I'm a server nerd, so seeing the picture of the server room is always fun. It's always a delight to hear about the changes. All right. So next up, we have Christopher Bellman, who's going to talk to us about how the 4th year security course runs its assignments on OpenStack. And this is one that I'm pretty excited for because I've participated in them before. I think that it's a great way to go through like assignments, is actually like getting students in the thick of it. So Chris, I'll pass it over to you to get started.
Thank you very much. And so just to collect my thoughts here, I put together a very brief slide deck. So if I can share that, I assume I can share. There's no perfect. Okay, everyone can see, everyone can hear.
Perfect, looks good.
All right, so yeah, my name is Chris Bellman. I'm I guess what we'd call a veteran PhD student here at this point. In my 5th year, I'll be defending my dissertation next month. But for the past 7 semesters, I have been the TA for Comp 4108, which is Computer System Security. And it's been, over the past number of years, I've learned a lot about OpenStack and how it sort of works, and how we've been able to use it with Comp 4108, and sort of over time we've been able to make sort of additions to what we do to use OpenStack in sort of interesting ways, which I think are pretty interesting. So I've just got this little presentation here. I'm not going to take probably near 15 minutes, but I'm just going to go through and sort of just talk about what the course is and how it relates to our use for OpenStack. So just the primary use of OpenStack for, or I guess the entire use of OpenStack for Comp 4108 is purely in its assignments. So as I'll get to on the next slide, we have a total of 5 assignments that they do throughout the course, usually like 2, sometimes 3 weeks per assignment. And each assignment consists of basically of one OpenStack snapshot. So just a virtual machine that we've set up there with any assignment stuff that students are going to need, and they can go in and manually spin up a virtual machine and an instance as they need it. So they go in, they pick one of the 5 assignments, which they inevitably a number of students always pick the wrong VMs, and they always have problems. Why won't the software work? Blah blah blah. It's pretty funny. I mean, I feel bad for them, but every time it happens. So they go in, they manually spin it up if they pick the right one, and then they follow sort of the assignment documentation that we give them. So what's convenient about this is that we don't really have to provide any other services to the students. Everything that they need for the assignment is either in the VM or software that they can download on their own that will essentially interact with the VM. So I'll get into a little bit more about that again on the next slide. For any sort of services that are running on the VM that they can't access directly just through the firewall rules and whatever, they can go through the SSH tunneling and sort of forward their ports in to get into whatever it's web servers, or actually primarily web servers in their VM. So it's useful. That always sort of causes a little bit of an issue, but once they figure it out, it's typically something that everyone's able to do fairly easily, and they can get into it just fine. Now, unfortunately, with sort of some of the issues we've had in the past, with VMs being, I'm not going to go out and call it unstable, but we've had some hiccups just in the past little while, which sounds like it's being addressed, so much appreciated. We basically give sort of there's no warranty given to students. When they're using the virtual machines, we tell them, hey, these are ephemeral, you're going to destroy them afterwards. Make sure you're backing up your stuff a lot. So we basically tell them, if you're going to write code, write it on your local machine, copy it over. That way they've got backups no matter what. And if they screw up their own VM, they can just destroy the VM, make a new one, and put their stuff back into it. So it's our course treats virtual machines very ephemerally. They're very they're quick to be created, they're quick to be destroyed. We use them for the assignments, and it's very, very useful that way. And as I'll talk about in a sec, all the assignments sort of make use of the OpenStack virtual machines differently. So as I said, we have 5 assignments, and I'll get into this in a sec. So the first assignment formally, as of sort of last year, we used to have the first one being password cracking, where students would go in, they'd run password cracking tools, John the Ripper, to try to crack passwords, and then they'd also try to sort of do online attacks. So there's a web service running in their VMs that they have to try to break into. It's a fake social media site, which is always pretty fun for the students to get into. Unfortunately, we lost that assignment to, I think, one of the 3rd-year security courses. They have that assignment now, I believe, which is unfortunate because it was my favorite one to go through, and the students always had a great time with it. So now in the first assignment, we've sort of shifted things around. The first assignment, they're doing like Linux file system security stuff, they're doing permission stuff, they're doing stuff with ACLs, and they do stuff with race conditions just in Linux there. In the second assignment, they're writing Linux kernel modules, or more specifically a rootkit, to help try to hide files within the operating system and give themselves access to things that they normally wouldn't have access to without it. I would say that's typically the hardest one for the students. That's the one they struggle with the most. So it all sort of, I wouldn't say it goes downhill from there, but in terms of difficulty, I think some students struggle with that one, but in general, they find the assignments pretty fair. In the third assignment, this is a brand new one because we had to come up with a new one to replace the previous password cracking. It's all about sort of certificates and creating certificates and validating certificates and doing public key and symmetric key encryption and decryption. So what they do is we have a web server where they create a certificate and they send us the certificate, then we send them back. We sign their certificate and send it back, and then they have to use their keys to encrypt data for us, and we send it back to them, and we do a bunch of back and forth stuff like that. And so that's pretty cool how we can sort of interact with the students that way. And in that case, they use their OpenStack VM not so much for software or like sort of a main process that they're going to use that we have pre-installed for them, but more of just a place for them to develop and get some of the keys that they need for the assignment. In the fourth assignment is web security, where they use 2 tools called Burp and Beef, and then they go into something called the Damn Vulnerable Web App, DVWA, and the Magic Code Injection Rainbow. And what that is, it's basically their web servers hosted in the OpenStack virtual machines that they can go and they can just try to attack. The damn vulnerable web app is a tool, a learning tool that has a whole bunch of vulnerabilities. You can change sort of the difficulties, and they have to go through and do a bunch of different things to try to break that for that assignment. So that's really cool how they can not have to worry about installing any of that software on their own machine and running sort of unsafe stuff. They can use the virtual machines on OpenStack to then just go and attack and play around in without really a whole lot of consequence. So it's great for learning, and it's a safe environment. And it also means that students aren't sending a whole ton of malicious traffic over the internet to something because they can just do it all locally in the virtual machine, which is great. And then the final assignment is sort of directed towards more network security sort of stuff. They're doing things like port scanning. They're using Linux IP tables. They're doing Nmap and then learning how TCP dump works to be able to basically create firewall rules and scan hosts that are on the network and sort of try and determine what different hosts are on the network and whatever. That one's always interesting because it sort of highlights the students, because it's sort of, a lot of them don't have much of a networking background when they come into that. So it's really interesting to see how the students sort of relate how they use OpenStack and to get into their OpenStack VM with their like SSHing to an IP address and how they connect that with port scanning and what all the other hosts are in the OpenStack network for them. So it's really interesting to see them sort of try to combine those two pieces together. Some students don't have problems with that because they might have a little bit of networking background, but it's an interesting exposure for the students. So the general flow of the assignments is we have a website that we have here that just has all 5 assignment documentation. I release them one at a time, and they go look at the website and they basically just they have the OpenStack virtual machine. They just go through down the list and they do the things in the assignments. They answer questions, and typically they put together a PDF with the answers and they just submit that with their code. And then I go through and I mark it afterwards and blah blah blah. That's normally kind of it's a painful way of doing it. So what we've started to do, and the effort has just been in the past year or so, to try to create what are essentially automated sort of marking servers and interactive servers. So as I was telling you about in the assignment 3, the certificates assignment, these students interact with a web server, and every time that they send a message to the server, we validate it. And if they've basically done the correct thing that we had in the assignment document, we give them marks for that just automatically. So they're interacting with it and they're getting feedback on exactly if their keys are correct, if the just anything they've done, if their certificate was able to be validated correctly, anything that they do, we can just automatically give them marks for it. So it's this interesting interaction between the students, their VMs, and sort of automated submission. Now that saves me a lot of time, although I sort of put an asterisk there because it's taken me a lot longer to develop those systems than it has saved me so far. But future TAs will get that benefit, fortunately. The assignments for Comp 41 and 4108, and Forrest, as you said, you took the course, you've done the assignments. Students always seem to love the assignments in this course. I mean, I personally find them super interesting. They teach you a wide variety of security topics. They cover both sort of red and blue teams, where you're doing sort of offensive stuff, you're doing sort of defensive stuff. They're very practical. You're learning a lot of really practical skills. Even if you're not going super deep, things just like basic networking stuff, port scanning, web security stuff, like you don't go super deep, but you learn sort of some neat stuff that you might want to follow into afterwards. And so it's pretty cool. I always get a ton of compliments every semester that students love the assignments in the course. So historically, this is my understanding, and I know you might be able to fill in some of the gaps here, because I know sort of little of how things were done before the course started using OpenStack. To my understanding, the student VMs, sorry?
Yeah, we just had VMs running in our lab infrastructure.
Yeah, so
basically it. Yeah.
Yeah, so much it was a much less infrastructure-y, to use a not real word, way of doing things. So the student VM images, to my understanding, were run on one of our CCSL servers in the CCSL just down the hall from the current servers. And then for each assignment, the TAs had to manually go through and remove any old VMs that were there for previous assignments and spin up new ones, Presumably they probably had scripts or whatnot for that, just a guess. But in general, the infrastructure then had to be managed by either the TA or lab members or professors that were in the lab. It wasn't sort of a dedicated team that was there to help support these sort of courses, which we have now with OpenStack, which is great, and it saves us a ton of issues, and it's very helpful. Another thing, students generally had no access to their own VM management. In order to spin up new VMs, the TAs would have had to do that and deal with all that. It's already a pain to deal with the student VMs in OpenStack currently, just as with all the students, and I'll get to that in a minute. It would have been even worse if students could even spin up their own VMs and whatnot. Now, again, I don't know if this is all completely accurate. This is just based on what I've been told in the past. So in general, prior to OpenStack, wasn't the most ideal situation for everybody involved in both the TAs, a lot more work for the TAs and for the students. They had less interaction. They didn't really get to use some of the same tools that they are now familiar with OpenStack. And so, yeah. So that was sometime before 2019. I'm not exactly sure when it was, but because 2019, I think either fall, maybe, was the first semester that I took over as the TA for Comp 41.8. We were using OpenStack at that time, so I was fresh onto that, and it's been a great tool for us so far. So just to sort of cover, I mean, now I've given you the background of what we do in the course and what we use OpenStack for. There's sort of a few advantages that I want to highlight of OpenStack and why I think OpenStack is useful and other courses should use it. The first is that it's easy to manage. It's great just having one central source for me to manage. It's just a web interface. I can load it all up. I can see all the student VMs. I can determine who's doing what assignment, who just spun up a fresh VM 30 minutes before the due date or deadline. It's great to be able to see that all. And then I can clear off any old VMs very easily. I can spin up new ones for testing, blah, blah, blah. But it also gives the students that same ability. They can go in on their own. They can spin up their own VMs. They can stop their old ones. They can move IP addresses around. It's great. It's great, easy to manage. It's wonderful there. Second, it's pretty easy to update. In order for me to update some of the images, which I typically do every semester, I'm sorry for everyone else that has to see all our Comp 4108 images in the list. I can spin up a VM that I want to change. I can make changes, and I can save that snapshot for students now to go and spin that up. So it's very convenient, just like nothing super special there. It's, yeah, very convenient to do and generally pretty quick. The third point, it's easy for the students to explore, we'll call it. Students don't have to really worry about messing up their own systems. They don't have to really worry about messing up any systems in general because of how sort of ephemeral we treat the instances. They can go in, they can explore, they can try different commands to do different things. And if they screw up so much that it's unrecoverable or whatever, they can just delete the VM and spin up a new one. And I sort of give this one an asterisk because that's not only useful for the students, but it's also really useful for the TAs. Sometimes if we don't know exactly what's wrong, or if students have sort of done too many commands that it would take a while to get back to sort of a safe state, we can just tell them just to destroy their VM and make a new one. And typically that just puts them on sort of a nice clean path again. They'll have to copy all their files back over, but they're generally pretty good at that at this point when they need to do that. So it's great for students to learn things like that. And in general, their use of OpenStack, because all of our images run Linux, they learn a lot of just really useful things by interacting with the system. So primarily they use Linux. They've learned Linux more if they haven't already, and we sort of include some learning stuff within our assignments. And they learn basic networking things like how to SSH into a machine, how to copy files, the basics of virtualization, all those sorts of things. And just thinking back on my own experiences, one summer I did an internship at BlackBerry before that kind of fell apart. And a lot of the questions they asked me during the interview were sort of all things that basically students are learning about now in this course with all these basic things, how to SSH into a machine, how to do sudo, what that means, all the basics of sort of security things like permissions. So it's just a very convenient tool that not only facilitates the items that we want them to learn for the course, but then also all these other sort of very practical things that the OpenStack cluster allows us to do. They learn a lot, they can get all the course material, and it's super convenient for us, and we appreciate the all the work that the administration does to keep all these servers up and running for us and for the students. They all appreciate it very much so. So that's sort of my overview of what we do in the course, why we find OpenStack very useful, and hopefully this sort of sheds some light into how we use it and why others might want to use it. Maybe it's a good case study for you.
Perfect. Well, thank you very much, Chris. It's definitely really great to sort of see into the mind of someone who's using it for courses and kind of like the thought process and a little bit of history too. I'll open it up to a few minutes of questions here if anybody has anything that anybody's wondering. And if not, I have a few things myself. One thing I was curious about is for, I think it was the last lab, but you described that they're using like Nmap and networking type of stuff. I was curious if doing this type of, so if they're Nmapping their own device to find stuff that's running, that's fine. But then if you're Nmapping within your subnet, I was curious if that ever had any ramifications on like just like networking on the host boxes themselves, like either if you know or if Andrew, you know.
Well, so what do you mean by ramifications, first of all?
Well, so whenever I go to like, just from what I've experienced, I go do like a capture flag competition, and then they'll either tell you up front, you are allowed to do enumeration, you're allowed to Nmap, you're allowed to do everything against any piece of the network. We've built infrastructure so you can do this. Or on the other hand, they say you're not allowed to do this. And if we catch you doing this, we're gonna kick you off and like give you like timeouts and stuff like that. And so it's ramification just in the sense of overbearing the network.
No, so what we generally try to keep them away from doing like full port scanning of all the hosts on the network. We tell them specifically to do just basic, just like ping scans of everything that's in their subnet. Yeah, that might be a little bit taxing for the network, and we apologize if it is. Typically, they don't do it very often. It's not like they're running a huge amount. So, I mean, maybe there is. I suppose, Andrew, you've been in a better position to explain whether or not you see any issues with us doing that so far. But no, for the most part, they're just scanning all their local machines. There doesn't seem to be any issues. A lot of students have trouble determining what they're seeing. They can't quite piece together what Nmap does with the fact that they're scanning their own local network because, again, they don't really have the networking background to know what a subnet is. So they get very confused by that. And it's interesting to sort of watch them try to piece that together. But no, I haven't had to punish any students for doing something that they shouldn't be doing.
Yeah, we definitely haven't seen anything on our end. So it's like the servers are obviously all connected 10 gig switches with 10 gig NICs, and also like it'll often be like OpenStack will stage it so that it tries to balance systems, but it'll typically group systems on nodes that already have the image deployed to minimize the amount of image copying. So it'll go up to a certain threshold and then it'll start spreading them out a bit more. But you'll often end up the way we have it balanced where a course will have a fair number of people on just a few nodes. And the networking internally, like if you're hitting another system that's on the same node, it's actually never leaving the virtual network. It's typically not going over the wire at all. It's just going within the network, the virtual network setup for the bridge. So
it must be pretty quick then.
So
yeah.
it's all within the CPU essentially. So
yeah. Okay, that's good to hear, because like I run like capture flag competitions on OpenStack infrastructure sometimes, and so if this was more me asking Chris in a way that I could blame you for stuff that I've done in the past, but yes, it's good to hear. It's good to hear that there's not, and I suppose if I were to do something that were a problem, I would hear about it, so it's all good. All right, well, thank you very much, Chris, for this overview. It was really great, and also, yeah, if anybody else has questions, feel free to put them in chat, and Chris can take a look at them. So I'm going to try sharing my screen here, and we'll see if, does this work? Did it work this time? It did? Okay, perfect.
Good.
All right, so I just wanted to finish off today's meetup with just a little bit of updates from what we're doing on the student side. So primarily what projects we're working on this summer. And so at the last meetup, I talked a little bit about the big one would be discretemath.ca and how we were working on it. So it's deployed on OpenStack, but for the most part, it's not very intensive. It doesn't have like a really strong backend, or it doesn't have a backend that requires a lot of stuff. And so we're working even on moving more of the front end side of things to some CDN server, presumably like GitHub Pages or something like that. And the biggest reason for this is the content that we're serving. It's primarily static. We designed it as a dynamic thing with a backend web server because it was like a good learning experience, and it was really cool to kind of see everything working in tandem. But for discretemath.ca, we're working a lot more towards putting it into a static just like content distributor. We also have a few other products that we're doing this summer. And so just like to quickly go over some of the smaller ones. So student.carletoncomputerscience.ca is going to be a site that students can go to find out, as far as I know, just like stuff about like courses at Carleton, information from upper year students. It's just a compendium of knowledge from the CS students. Friend Zoner is a Discord bot that we run on our computer science Discord server. And the idea behind it is that like if you have 20 people in an audio channel, you can like shuffle them into different rooms so that we can do like speed friending, which like gives you the ability to just like talk with new people and meet them in like a 5 to 10 minute session type of thing. So like those are the smaller ones, or like small things running here and there. But one that I want to talk about a little bit more is AutoGrader. And this is like a work in progress name. But before I do that, I also quickly want to mention some of the stuff that's going on, like how we're approaching projects this summer. And so last summer we had like a small group of people that we like personally invited. So I'm like one of the co-leads of it, and Matthew McRae-Boval is the other. And we found some people that were invested in creating content for students. So primarily discretemath.ca. And it worked really well. Like we were able to get a lot of stuff done, but we really wanted to try and take the method that we did and get more students involved. And so we're experimenting with what works and what doesn't work this year. We have a few more projects, and then we also have like our like this team on GitHub. So we had like a sign up where students could come sign up, and then effectively they can go get like issues that they can assign to themselves and then work on, and then we'll review them and get them merged and everything like that. And so it's going pretty well, and it's allowing us to sort of spread out the amount of work that we have. Of course, there's a massive upfront cost, like there is with any project, where you have to specifically make like beginner level tasks for people to get started with. But then the return on investment is very, very high, because you have these students who have now been contributing to open source projects who can come back and then take initiative themselves. And so this is really what we're trying to build. But I want to go a little bit over AutoGrader. And I got like the thing down here. So we were talking with Professor Heineck last semester about how when it comes to like the 2402 course, we have essentially assignments that get submitted, and it's like a data structures course. And so each assignment will ask you to implement some stuff in Java. And if you don't use the right data structure, it's going to take too long to run, or it's going to take too much memory. And this is like a really good way of doing assignments, in my opinion. But one of the issues with it is that whenever students submit their assignments, all of the code has to run on a single server that I think the CG lab runs. And so we're taking a crack at rebuilding the system from the ground up, so that at its core, it has a more distributed scheduler that can schedule jobs across different virtual machines. And so we're designing it so that it runs in the OpenStack. It can schedule jobs to several different runners, potentially on different hosts. And the biggest reason that this matters is, as we all know, the assignment deadline comes up and students are all submitting in the last 30 minutes. And then it removes the issue of too many people doing work on the same computer at the same time and then getting incorrect results of the runtime. And like there's the argument that this isn't a bad thing, like it's your fault for leaving the assignment for this long. But I think also in this project, like our goal isn't just to solve the problem for 2402, but also to try and make a system that other courses could also use if they want to submit assignments that need to get graded on some server. And so we have a front-end team working on this. We have a back-end team, which is pretty small right now because I haven't distributed my tasks too well. But we do have some initial prototypes of like the different components a little bit separated. But we're trying to get something ready for the fall. and so either it could be used in courses or like prototyped for like an assignment and just kind of see how it works. But this is definitely like a really cool one that I'm excited that a lot of students are able to help out on. And so one more thing. Okay, so discrete math SCI, I guess I have the slide here. For people who don't know, it's essentially gives you practice questions for the discrete math courses at Carleton. And so 1805, 2804. We'd love to do 3804, but it will take a little bit longer to find some content for that maybe. So this summer, we're primarily focusing on getting content for 1805, just because up until now, we've only focused on 2804. And so, okay, we also have students. Actually, I don't know if this is it's coming soon. That's pretty cool. So, okay, friend zoner is a bot. I'll just speed along to some of the last things here. So one initiative that I'm trying to do is, because we are setting up this larger infrastructure that allows us to very easily run containers that get automatically scheduled across hosts, which I mean is going to be useful for AutoGrader to be able to schedule different jobs across hosts. We're using a tool called Nomad, which is similar to Kubernetes, but it's like a lot more scaled down. And one initiative that I want to try is having students who want to have projects running have the ability to make a request to get something hosted. And so this request, the requirements are that their project must be open source, that like there isn't anything malicious, and then we like take a look through the code base, but then we can go and put it on our cluster that's managed. And so we really like, I'm hoping we can ramp this up this year in getting students to come out to different activities and try out like these types of like learning about what it takes to run a backend server, run a front-end server, run a Discord bot on like a server that will be up all the time. And then finally, I want to talk a little bit about a student dev machine that I have. And so the bigger problem that we had in getting, and I guess one of the reasons we didn't do it before, in getting just like 30 students to come work on projects, was that it is so terrible trying to set up everybody's environment to have, okay, it's like one of the projects uses Hugo, one of them uses Jekyll, which is Ruby. I think Hugo is NPM. And then a lot of the projects I'm doing have like a Rust layer at the bottom. And then we have like Django, which is Python, and so on and so forth. And so a lot of different frameworks and languages and environments are required. And so what I did was set up a dev machine. And what I mean by this is it's just one virtual machine that has like 64 gigs of RAM and probably like 16 vCPUs or something. And then I'm making use of VS Code's ability to remote SSH into a device or a server, which is pretty much just like, it doesn't mount the files to your local file system. I guess maybe it artificially does it in the same way that rsync does, but you can go in, you can see the file system as if it was local to you. You open a file, it downloads it from the server, and then as you make changes, it makes the changes on the remote file system. And then that's one side of the thing, like that they can SSH into this Linux box, and that's great as is. But then the second part of it is that VS Code also has this really cool extension called dev containers, which essentially starts a Docker container, installs all of the requirements that you specify in a dev container config, and then allows you to SSH into there. And so effectively, by setting up this initial environment in the config file, I can get each one of these students, no matter what project they're working on, to SSH into a unit that allows them to just instantly start the startup commands. And this works from, I mean, you're SSHing to a different device. So if you're on Windows, Mac, or Linux, it's all fine either way. And so we have like this set of instructions. The one thing I regret is like trying to get them to use the fancy elliptic curve keys, only because like the dev containers don't automatically bring them into the box. And so I have to like tell them, okay, you got to exit the dev container to SSH so that you can push to GitHub. But relatively speaking, it's been okay for students to do this. There's definitely been a lot of complications, and I mean, when it comes to understanding what's happening under the hood, there's a lot of discrepancy there. Like I'm abstracting away a lot of the idea of what SSH is actually doing, or like even like what like Linux boxes are giving them in general. But it has allowed students to make their first pull request by changing some code, seeing it run locally. And also like another benefit of these dev containers is you can like forward ports to yourself. And so if you're running a server on port 5000, you can access it locally. And so for me, like the biggest hurdle was like, what does it take to get their first pull request on GitHub? And after that point, then I I mean, there's gonna be a drop off of like anything, but hopefully we can like retain a few students who keep pushing forward, keep working on stuff. And so yeah, so this has been a cool thing. I kind of want to see it like scale for different things that might be run. I don't know if it would fit in courses very well. I think that there's definitely downsides of like running everybody on the same box. Like, I mean, if someone suffocates RAM, then it's gonna kill it for everybody else. But other than that, it has been working pretty nicely. Yeah, so that's it for my side of just what I wanted to update on the student side. So I'll quickly see if there's any questions that anybody has, and then other than that, we will end off the meeting. But any thoughts or questions from anyone? Just find one.
Just a comment, if I can. I really like how you've sort of focused on GitHub stuff. Coming up through my undergrad, I didn't do my undergrad's not in computer science, it's in networking. So we weren't quite into as heavy CS stuff and programming stuff, but a lot of the knowledge of GitHub that we sort of had to learn on our own is very useful stuff to learn. And I like how you've integrated it with all these other sort of these little features that you're working on to help the students learn about them. And if the students can learn about how GitHub works and pulling and pushing and requests and whatever early, I think that's going to be a really useful tool for people to learn by interacting with you in the systems like this. I think that's really cool.
Yeah, thank you. I think Git and GitHub is something that's assumed to be understood by students by the time you get to third year. But I definitely do a lot of work to make sure that students ahead of time like get some exposure to it. So in 1501 Intro to Game Dev this year, like as a TA, I really got students to work in GitHub for everything in the second half of the semester, which I think is gonna, I mean, they're gonna work with other students. They're gonna make other students use GitHub. So I hope that it has like a large branching effect here, but absolutely. I'm also like a GitHub campus expert. So I get to like run events in like like that like can be sponsored by GitHub and stuff like that. So it's always cool to be able to show more people about the cool stuff going on. So yeah, I love to see it. All right. Any other questions? Okay. So thank you everybody for coming out to like the second meetup. I want to try to run these maybe every 6 months. I don't know exactly what cadence, but I think it's just a good opportunity for people who are interested to see like what kind of hardware stuff is going on. So maybe we can have one sometime in the fall. And I'd love to. I mean, today I think last time we had like 5 people, and so we have 10 today. And I kind of forgot to like mention anything to anybody until yesterday. So next time I'll definitely make sure to get more people in on it. But it's always good to see lots of people out here. So thank you very much for coming out, and I will stop the recording here.